Today I will be going through some more of the STAR practice questions. We are going to start on number 20. You may already have these completed, and if you have those, you can look for them and find them. If not, there is another packet for you to follow along with. So on number 20, you have a graph of an equation, and it's in the form y equals mx plus b. It wants to know that, based on the graph, what is the value of x when y equals -7? So what we're going to do here is we're going to take a straight line, and when y is -7, we're talking about right here. See if I can get the line to draw. Okay, there's where y is -7. Okay, you have your y-axis right here. And so we go down to -7, and I just drew a line where that is. And we want to look and see where they cross. Well, they cross right where I'm putting that red dot. And that's when x is. I'm going to draw a straight line again. Oops, not where I wanted it. So I can rotate that or delete it. Let's try to draw that straight line again. It doesn't want to start where I wanted it to. Basically, it's at where x is -5. So that would be the answer that we would grid on the document, -5. Moving on to number 21. When a contractor paints a square surface, and I'm going to circle the word square because that's going to be important for this question, that has a side length of x feet, he needs to know the area of the surface in order to buy the correct amount of paint. Okay, so if this is a square surface, both sides, all four sides are x. Since the contractor always adds 25 square feet to the area, he buys extra paint. Which function can be used to find the total area in square feet that the contractor will use to determine how much paint he needs to buy? Okay, so I think this plus 25 is really important to this, which is how we can eliminate A and C because they're not adding 25 to anything. Now on D, he's just adding 25 square feet. He's not adding 25 to the side. Okay? He's going to find the area of the square by doing x times x, which is x squared, and then adding 25 to that. So our answer that we're looking for is D. Moving on to number 22. This graph shows the change in the value of a car over several years. So based on the information in the graph, what appears to be true? Okay, so we're going to look at each of these answer choices and decide if this actually is verified by the graph. So F says the car lost about half of its value every 3 years. Well, let's look at that. So at first, it appears to be 12. And so 3 years later, it appears to be worth 6. That is half. Okay, 3 more years later, at year 6, it appears to be worth a little over 4, but that's not half. Okay, so for F to be true, it has to lose half of the value every 3 years. So we can eliminate F. G says the car lost about 1/4, which would be 1/4, or divided by 4, of its value every year. Okay, so I'm going to erase, not erase. So it starts with 12. After 1 year, it goes down to 9. Okay, so 1/4 of 12 means that it would lose 3. 12 minus 3 is 9. So that is true. Okay, then it goes from 9 down to 7. Okay, so let's see what 1/4 of 9 is. And we get 9 over 4. That's about 2 1/4. And when you do 9 minus 2 1/4, you get less than 7, but it says about. So we have to be careful with that. So that one's still possibly about right. When we go from 7 to 6, though, okay, year 2 was 7, year 3 is 6. So 1/4 of 7 is 7/4, which is 1 3/4. That's almost 2 that it would lose from year 2 to 3. And it only lost 1. I would say G is probably not it, but we do need to look at H and J before I make our decision, because G was definitely better than F. So looking at H, the car lost less of its value between 9 and 10 than between 1 and 2. Okay, so here's between 9 and 10. It lost very little value between years 9 and 10. But between years 1 and 2, right here, it definitely did lose more there. So H is much better than G, so we can go ahead and eliminate G. And then J is actually the opposite, saying it lost more of its value between 9 and 10 than 1 and 2. So that's not true. It lost more value between years 1 and 2. So H is our answer. In question 23, we want to know the equation in standard form of the line that passes through a given point and has a given slope. Now, what I would do on this one, personally, before anything else, if you look at all of the answer choices that you have here, every answer choice has a positive x, no number in front of it. The y has a -4 in front of all of them. The only difference is this number. So all of these equations are different. So the best thing that you should probably do, that would be the most likely to get you the right answer without making a mistake, is to just take the ordered pair 4, -8, plug your 4 in for your x and your -8 in for your y in each equation. Just trial and error. So let's start with A. So x minus 4y equals 36, so that would be 4 minus 4 times -8, and we're checking to see if it's equal to 36. So you can't do this, you can't do a graph like we've done before because it's not in y equals form, but you can just go into your graphing calculator and do 4 minus 4 parentheses -8 close your parentheses, and then press enter, and I get 36. That works. So we should be pretty certain that A is our correct answer. Now if you want to just verify it, we would do the same thing for B. We would have 4 minus 4 times -8, and it says equals 28. So here's the thing. If you notice, all of these are the exact same. So no matter what I do, I'm going to be plugging the same numbers in. When I plug them in, I got 36. That means A has to be our correct answer. Question 24 has us setting up a system of equations. And that's all you have to do in this particular question, is set the system up, not even necessarily have to solve it. So you have a new spiral notebook that contains 30 more sheets of paper than a new memo book. The total number of sheets of paper in 3 new spiral notebooks and 5 new memo books is 810. Which system of equations can be used to find S, the number of sheets of paper in 1 new spiral notebook, and M, the number of sheets of paper in 1 new memo book? The very first thing is that you have the spiral notebook and the memo book. Okay? And the spiral has 30 more sheets of paper than the new memo book. Okay? So on this one, if you take S minus M, spiral minus memo, you should get 30 because spiral was larger. So that gives us F or H, and that way we can eliminate G and J. They say S plus M. Together they don't have 30, so those don't make sense. Then 3 goes with the spiral. Okay, so here's 3S. That says 5S. 5 goes with the memo. And then together, total, they have 810 pages. Oops. Should circle those. So our answer would be F. On to question 25. This is a great example of something that you can graph and check. Okay, you have the original function right here, and we want to know one that is equivalent to it. So we're going to put this into your y equals. Okay, all of this that I underlined is going to go into your y equals on your graphing calculator. So we're going to click on the y equals button and type in 6x squared minus 13x plus 5. I'm going to go ahead and graph that one just to look at it. If you need to, remember zoom 6 gives you back that standard window. It's just the easiest way to look at it. Now, I've already seen it. I'm going to go back into my y equals, and in my y2, I'm going to type in the very first answer, A. So I'm going to type in 3x minus 1 in parentheses. So 3x minus 1, and then close the parentheses, open them again, 2x plus 5. Make sure you type it in exactly as you see it. Now I'm going to graph that one. That is definitely not the same graph. So we are going to eliminate A. I'm going to go back into my y equals now, and I'm going to change that equation to 3x minus 5. No need to clear it out, just change the numbers. 2x minus 1. When I graph it, it looks like it could be the same graph. Now, just in case it's out of the window and I can't actually see it, I'm going to go ahead and I'm going to try the next two, C and D. C being 3x minus 1, 2x minus 5. I'm going to go ahead and graph it just to see, but right now B looks like it's our answer. Okay, C, once you graph that one, you can definitely see it's not the same graph. So let's do D just to make sure, and that's 3x minus 5, 2x plus 1. And definitely not the same graph on that one. So that verifies, that helps us understand for sure that B is the correct answer. On the next page, number 26, we see that the average blue whale gains weight at a constant rate each day during its first 6 months of life. The relationship between the average blue whale's weight in tons, W, and its age in days, D, for the first 6 months of life can be modeled using the function W equals 0.1D plus 3. Based on this relationship, which statement is not true for the average blue whale? Because I have an equation that's in form that I can graph it, I'm going to go into my graphing calculator, clear everything out, and I'm going to put in this equation. 0.1, instead of a D, we'll put an X, plus 3. And we're going to graph it and look at that graph. And so it's a straight line. So we're going to look at F. It says the average blue whale weighs 3 tons at birth. Okay, we're looking for the statement that's not true. If you zoom in on this, and if you'll just look at the equation itself, you'll see that it crosses. I'll zoom out because it zoomed in too much. You can see that it actually crosses the y-axis at 3, meaning that, and also this being the y-intercept right here, it starts out at 3 tons, and that was how we're measuring the weight, is in tons. So that is true. We're looking for the one that's false. When the average blue whale is 5 days old, it weighs 20 tons. Well, that's where the graph is going to come in handy, because I'm going to trace a 5 for 5 days. When I trace a 5, I get 3.5. So G is probably our wrong answer. The H that says it gains 0.1 ton per day during the first 6 months, okay, that's where the slope is, what the slope is telling us, how much it gains per day. So that one was true. And J says it weighs 18 tons when it's 150 days old. So if I trace a 150, it's going to give me an error. I'm going to have to zoom out. Zoom 3 and enter. Let's see if that gives us enough. Tracing a 150. Still not enough. We'll zoom out one more time. Hopefully that will give it to us. Trace a 150 again. 18. That is true. So you had to zoom out several times, but when you zoom out several times, you get that it is 18 tons at 150 days old. So the incorrect answer was G. For number 27, we have two quadratic functions. G of x is 5x squared minus 12, and k of x is 5x squared plus an unknown c. We want to know what c has to be if k is actually 9 units above the graph of g. This right here tells us where it crosses the y-axis. So 9 units above negative 12 would actually be at negative 3, and that would actually be the answer. For number 28, a customer pays an annual membership fee of $85 to a neighborhood car wash. Each time he takes his car to the car wash, he pays only $7. The total amount of money he spends at the car wash in 1 year in dollars can be found using the function y equals 7x plus 85. What does x represent? Well, $85 represents the fee he pays that one time a year. The 7 tells us how much he pays each time he goes to the car wash and washes his car. So x would be the number of times the customer takes his car to the car wash in 1 year. Number 29. The owner of the store buys large boxes of candy bars from a warehouse and repackages them to sell in smaller boxes in his store. The store owner packages 4 candy bars in each small box. Each large box contains 24 candy bars. Which graph represents the relationship between X large boxes and Y small boxes? Okay. So what we see is that he puts 4 candy bars in each small box. Okay. And each large box contains 24 candy bars. Okay. So if he has one large box, right here, one large box, it looks like we have the same amount as if it was 6 small boxes. Well, 6 times 4 is 24, and 1 times 24 is 24. As this represents the number of small boxes. There's 4 candy bars in each small box. This represents the large boxes, 24 in each large box. So A looks like it could be the answer. Because in B, if he had 6 large boxes, 6 times 24 is a large number. 1 small box, that would only mean 4 candy bars. So B isn't nearly big enough. C is the same way. If he has 1 large box, he's going to have 24. 4 small boxes, he'll only have 16, because 4 times 4 is 16. And then right here, this is kind of the same as B, where the number of large boxes actually has to be less than the number of small boxes. So, our best answer is A. For number 30, we have the function L equals 0.8 t squared, modeling the relationship between L and the length of feet in a pendulum, and t the period of seconds of the pendulum. Which value is closest to the period in seconds for a pendulum that is 30 feet long? So we have to on this one. There's several things we can kind of do. I think the best thing would be to go ahead and take this and graph it. Okay, so go into your graphing calculator, and we're going to, in our y equals, clear that out, and we're going to put 0.8 x squared. Remember, the variable itself doesn't matter. We just use an x for everything. And we graph it. Now, I'm going to give myself a standard window because I had zoomed in. So I'm going to go zoom 6 so I can see it a little bit better. Okay, now if we take into consideration that t is our time, and so I'm going to trace each one of these values of f, g, h, and j until I get one that gives me 30. Okay, because my length is my y value, and I cannot trace y values, but I can trace each of my x's. So I'm going to trace a 5.4, and I get 23.32, not quite 30. Now trace 4.9. That one's 19, so it's getting smaller, so I really need something bigger than 5.4. When I trace a 6.8, I get 36.992. That's too big, so hopefully 6.1 gives me 29.768, which is very close to 30. So J would be the correct answer. And it says which is closest, so it doesn't have to be exact. For number 31, an airline passenger would pay $439 to fly to California. For this price, customers may check 2 pieces of luggage. There is a fee of $25 for each additional piece of luggage a passenger wants to check. Which function can be used to find the amount in dollars a passenger has to pay to fly with P pieces of luggage? P has to be greater than or equal to 2 because the other 2 don't count. So, on A doesn't take into consideration that there are 2 free pieces of luggage, okay? Because they're going to say 25 per anything, which actually that one, as long as you know that P is greater than 2. Now, on this one, I can see a P minus 2 here and a P minus 2 here. This one won't be the answer either because we're not taking into consideration the fact that 2 of the pieces are flying for free. So on C, I think that's going to be your best choice here because on D, they're dividing by 25. We don't want to divide by 25. We want to multiply by 25 because we're paying $25 for each additional piece, plus the flight for $439. So B is our answer. For number 32, there are 32 founding members of an organization. The function y equals 3x squared plus 32 can be used to determine the number of members in the organization after x months. Based on this function, which statement is true? So this would be a good one to probably go ahead and graph as well. And so we would go into our y equals, and we're going to type in the 3x squared plus 32. And graph it. And I'm going to have to zoom out on that because when I graph it, it doesn't show anything. So zoom 3 and then enter zooms out. That zoomed out too much. Let's change our window. If you press the window button and change your x min to 0, or change your x min to -20. Your x max to a +20. So x min -20, x max +20, but then change your y min to 0. And then graph it, and let's see how that looks. Still a little bit more zoomed out than I want it to be. F says the number of members in the organization increased by 9 members each month. Here's the problem with that answer. If you look at the graph, and I'm going to zoom out one more time just to look at the graph a little bit bigger, it's a parabola. And so parabolas actually increase by more as it keeps going, or decreasing depending on whether it's opening up or down. F is showing something that would be linear in nature. Okay? Now, G says at the end of 16 months, there will be 288 members. Well, I'm going to trace a 16. And I get 800. Okay, so G is not going to be our answer because it's saying there will be 288. H says the number of members in the organization will increase by 3 each month. No, again, we said this is not linear, so it's not increasing by the same amount each month. And then on 7, at the end of 6 months, there would be 140 members. If you trace a 6, you get 140. So J is our answer. 33 shows an example of a scatter plot showing the relationship between the number of baseballs used in 14 games and the number of pitches thrown in these games. So on the scatter plot, we're trying to predict how many baseballs would be used if 275 pitches are thrown. Well, 275 would be right in the middle of 270 and 280. So if I kind of go up, and I kind of take that line and make me a trend line with it, it seems to be around 100. 150 is going to be too high, 60 is going to be too low, and 160 is too high. So C is our best answer, 100. On number 34, we have a plane that can carry a maximum cargo weight of 160,000 pounds. A company uses one of these planes to ship 2,000-pound containers. The total cargo weight is a function of the number of containers in the plane. What is the greatest value in the domain for this situation? Well, if it can carry a maximum of 160,000 pounds, and they're shipping 2,000-pound containers, this is really just 160,000 divided by 2,000, which is 80. On number 35, what is the x in the solution to this system of equations? I think the best way for you to do this is really to just plug in your numbers. Now, we could look at this and say it's probably going to be one of the fractions just because, but let's go ahead and let's plug in the 2 to start with. It's the easiest one to plug in. We're plugging this in for x. So that would be 3 times 2, and we're checking to see if it's going to, what y is going to be. Okay. So in this case, that would be 6 equals 2y plus 14. Y would have to be, let's subtract 14 from each side. That would give me a negative 8 equals 2y. So y would have to be negative 4. Okay, if x was negative 2, or x was 2. Okay, so if that was the case, the answer would be 2 comma negative 4. So now we're going to take the second equation, and we're going to plug in a negative 4 for y. So negative 4 equals negative 6 times, x would be 2, plus 18. Well, this is negative 12 plus 18 gives me a negative 6, not a negative 4. So C is not our answer. So I'm going to erase this work. And we're going to try the negative 2 next. So now we're going to, I would say the next easiest thing to write in there would probably be the negative 2. So let's try the negative 2. And we're going to plug that into the first one. So 3 times negative 2 is negative 6. And that would equal 2y plus 14. Okay, we know that one's not the answer. So we're going to subtract 4. We get that negative 10 equals 2y. Divide by 2. And we get negative 5 is equal to y. Okay? So then we plug that into the second one. That would mean that our answer would be negative 2 comma negative 5. When I plug that into the second equation, I would have to have negative 5 equals negative 6 times negative 2 plus 18. Well, negative 6 times negative 2 is 12, and then 12 plus 18 is 30. So it's not B either. So that means we are going to have to work a little bit more with the, we're going to have to do the fractions. But again, I'm going to pick the biggest one, or the positive one first, so that hopefully we can avoid having to work with a negative. So we're going to try 10 over 3. We're going to plug that in for x again. So we're going to do 3 times 10 over 3. and that's nice, equals 2y plus 14. Okay. The 3's, when you multiply that in your calculator, you're actually just going to get 10. So 10 equals 2y plus 14. We'll subtract 14 from each side. Get negative 4 equals 2y. Divide by 2, and we get that y is equal to negative 2. So I'm going to take that negative 2. I'm going to plug it into the second one. So we're going to see if negative 2 is equal to negative 6 times 10 over 3 plus 18. This one I'm just going to plug into the calculator. So we're going to say negative 6 parentheses 10 divided by 3 close parentheses plus 18. It gives me a negative 2 when I type all of that in. So that one works. So our answer is A. And this will be our last page for today. So on number 36, it says the table represents some points on the graph of the linear function g. The graph of g was translated 10 units down to represent the function h. Which statement comparing the graphs of g and h is true? So if we're translating it down 10 units, that means that all of our y values are going to move down 10 units. Okay, so F says the x-intercept of the graph of g is 10 units to the right. No. Right implies left and right. It says translate it down 10 units. So F is not it. G says that g is steeper than h. No, a translation only moves something, but it does not change how wide or narrow it is. So G is out. H says the y-intercept of the graph of G is 10 units above that of H. Yes, okay, because G, where it was moved down 10 units, so G is higher than H. And J is like G, it doesn't have anything to do with the steepness. And finally, number 37 wants to know the solutions to this equation. Now, there's a couple ways you can do this. If you're not comfortable with changing the graph, you can plug in the numbers into the x until you get the one that both of them give you an 18. However, I would rather this be graphed. I would take, for example, the 18, subtract it from each side, and you would get 3x squared plus 15x minus 18 equals 0. This means that you can actually put that into your y equals on your graph. So I go into my graphing calculator, and I'm going to type in 3x squared plus 15x minus 18. When I graph it, I'm going to see where it crosses the y-axis. I'm going to zoom standard because I need to be able to see everywhere it's crossing. I can definitely tell it's crossing at a 1, so I'm going to eliminate A and C. And it appears to be crossing at negative 6, definitely not at 0. So our answer is B. And again, you can actually plug these numbers in, like I would do 3 times negative 6 squared plus 15 times 6, and do the same thing with the 1. And you want to see that they both would give you 18. So you don't have to graph this one, but if you can move the 18 over, then it's easier to do it that way. So for tomorrow's assignment, you're actually going to have a test over maybe not every single one of the things that we went over today, but it could be over things that I went over in today's video or things that we went over a previous day this week in class. And so we'll do that tomorrow.